Um, Hello, thank you so much for coming out tonight. It's pretty exciting. I'm not going to follow any notes, so bear with me here. I think it'll make it more interesting, but I might go off on a tangent now and then, or I might forget some stuff. So we'll have time for questions after. So if you're like, wow, that was a big gap, then maybe we can fill it after, okay? All right, so yeah, so tonight I'm going to talk about mini forests, my experience with them, and yeah, how they can be a great way of filling kind of ecologically degraded spaces in urban landscapes. So in small spaces, which you don't often think of with forests. And as noted, my name is Heather Shibley, and I am an ecologist, a landscape architect, and an arborist with Dugan Associates. So I kind of weaseled my way in through design, and now I get to do a lot of field work and arborist stuff, which is fun. Yeah, and then just at the bottom, there's Network of Nature, which was mentioned. Mini Forests is a project of Network of Nature, and then Dugan Associates. So before I begin, I would like to thank some of our collaborators and sponsors, so including Canadian Geographic, the Greenbelt Foundation, Green Communities Canada, Green Venture, the Landscape Architecture of Canada Foundation, Natural Resources Canada, the Toronto Zoo, Vineland Research and Innovation Center, and Wilder Climate Solutions. So they've all been involved in this kind of mini forest, Miyawaki forest kind of exploration within Canada. All right, so I've both studied horticulture and landscape architecture, and within both those programs, so first at Humber and then at the University of Guelph, I did have the opportunity to go out into the landscape and to learn about trees and how we might utilize them in our designs. We looked at different species and kind of their assets, some of their drawbacks and their strengths. But the problem with this method of looking at individual trees within a grassy landscape was that we were really utilizing them as objects, right? And we weren't really considering what was happening below ground, aside from maybe speccing certain soils or ensuring that there's enough kind of soil volume for a tree, but not really considering any of the ecology that's happening below ground. And especially not considering how trees have actually evolved for the most part in communities, right? They've co-evolved with many other species, not just trees, of course. Usually there's a myriad number of species that are involved in these forest communities, including fauna, flora, and microbes, fungi. So across the world, since last glaciation, so about 10,000 years, we've lost roughly 1/3 of our forests. The most alarming part, though, is that half of that loss has happened within the last 100 years. So that's a jump. So this is an image of the Amazon rainforest, and most of this deforestation is coming from agriculture and livestock and planting food for livestock. This looks quite similar. This is Southern Ontario. So yes, indeed, we are in a forested landscape, but now we're in a deforested landscape, right? So this part of the country would be primarily forest if it was left to its own devices, but it's mostly been cleared for myriad reasons. Yeah, so I'll show you. So this graph kind of shows the history of forest cover in Southern Ontario. So this is taken from John Riley's book. It's the Once and Future Great Lakes Country. I think it's a great book, I'm pretty sure. And so this shows how when Europeans first came to North America, Southern Ontario and the Great Lakes region was really a mosaic of different ecological communities, right? It wasn't just forests. There were savanna, there were prairie, wetlands, and forests that were kind of mixed in because the landscape was highly managed by Indigenous communities. And that was, the management was by creating clearings within the landscape so that there could be more diversity of plant communities. You can think about many of the fruit-bearing trees we have wouldn't do well in the midst of a forest. They do really well on those edges, right? And kind of those open clearings. Same with raspberry thickets. And also those clearings created perfect spaces for game to come and graze. And so it made it really easy for hunting. And then when Europeans came, we actually had an increase in forest cover, and that's primarily attributed to a lot of the disease that went rampant, and Indigenous communities saw lots of losses, and that management of the landscape ceased. And so there was a bit of a rewilding that happened around the Great Lakes. But then you get to about, like 18 to 1900s, and there is a steep decline in canopy. We went down to 6% forest cover at the turn of the 20th century. And since then, we've been steadily climbing, but we're nowhere near what we used to have in Southern Ontario. So with European colonization came the lawn, right? And the lawn was for the wealthy, but it was utilized in parks and kind of spread and inspired others. So now we have our own personal Versailles. So that's Versailles, isn't that sneaky? I was like pretty excited when I saw that slide. I'm like, yes, modern Versailles. So it's our North American version. So this method of landscape treatment has become ubiquitous. It has become so normalized that we don't really even think about it. And that every person has lawn around their yards. And we of course have it on institutional lands, in parks, and so forth. So this doesn't look like much, but this is a map by NASA of turf cover in the US. Unfortunately, I didn't have an image for Canada. Turf in the US covers about 2% of the landmass, but it is seen as a crop, utilizes more energy and water than any other crop in the US. And 5% of annual US emissions come from lawnmowers, apparently. So if you want like where I got those figures, you can check in with me later. All right, so let's pivot towards the Miyawaki method. This is a method that came out of Japan in the 1970s. This is an image of Akira Miyawaki. He was a botanist and a researcher who wanted to start restoring Japan's landscape. And notice that the only native tree or like forest communities in Japan were those around Shinto temples. So that's an image of a Shinto temple. And he went into these landscapes and started collecting seeds from the forest communities, not just of the trees, but of the shrubs and also of some of the herbaceous plants, and took a tiny bit of that soil and started propagating those trees and plants and tested a lot of different methods to see how to replicate these forest communities in not too long a timeline. And he came up with a method that we now refer to as the Miyawaki method, which I'm going to get into with these following slides. Am I talking too quickly? Okay, I'm gonna take this opportunity to have a bit of water though. I like it when you can see the next slide because then I know what I'm going to talk about. I don't, so we'll see here. Yeah, I'll just talk about this. Okay. So one of the big, one reason that people are so interested in this method is because it's apparently we're expediting succession, which is kind of true and kind of not. We're just kind of skipping a few steps of natural succession. So if we were thinking of succession from bare soil all the way to mature forest, these are kind of the general steps that that would go through. So we're skipping planting a field of herbaceous graminoids and forbs, and we're moving right into planting mid to late succession trees. And that this method also is trying to replicate sort of a forest structure. So that's really generalizing because forests are actually quite unique and different depending on what community you're looking at. But trying to take into account that there are generally different layers to a forest. So we have the canopy, subcanopy, understory, shrubs, and ground covers. Of course, you can have the same species in different layers, right? They might just be different ages, but trying to kind of utilize the vertical space just as much as the horizontal space. And then this is a bit of, this is contentious, and we've certainly had pushback from some folks because the planting density is really uncomfortable. It is recommended through the method, which is mostly proposed or promoted through Aforest, which is an Indian company led by Shubhendu Sharma, that the trees should be planted 3 to 5 stems per square meter. So you can think of like planting, we in our culture, and I can certainly speak as a landscape architect, we typically do like 7 meters on center or 12 meters on center, right? Creating a lot of space for each tree so that they can really spread out and they're not competing with anything. So this here, we're planting, I don't know, like 30 to 60 centimeters apart from one another. It's very tight planting, and these are some very big trees. But we do try, so this graphic isn't perfectly, illustrated, because you wouldn't normally put 2 canopy trees next to each other. I just didn't have the heart to tell my staff member who had made this to kind of change it. So just imagine that each square is kind of like this, right? You're trying to create a random pattern, but mix the different height classes so that there's a bit less competition at height-wise.
What's the scale you would be representing?
Yeah, so yeah, you're right. I took off the scale too. I shouldn't even. So each square is 1 meter. Yeah. Yeah. And shrubs can include like bearberry. It's a woody plant, but it's a ground cover, or running strawberry. So it's not necessarily all trees, but it is regardless very tight. And I would say it's kind of what it's replicating is, if you think of a forest where a canopy tree falls, there are a number of saplings that have just been kind of sitting there waiting, and they shoot up at that point, and they're very dense. And if you do start to count the density within forests, it doesn't seem super dense, especially if you have deer. So you can't count those, because those are like cheater forests, because there is no ground cover anymore. But if you go to a forest that hasn't been taken over by deer, when you count the stems, they actually are quite dense. It's just that a lot of them are quite small, so you don't realize that the densities are there. So this kind of replicates that moment of where sunlight comes and everything kind of shoots up. But of course, because there's a high diversity of species, they're growing at different rates. So they're not all going to be at the same height. Some will supersede others. So think of like if you had a black cherry and a hemlock, the black cherry is going to overwhelm the hemlock pretty quickly, but hemlock are pretty shade tolerant, so they're just going to hang out and they play the long game. So I should note too that there's usually recommended to aim for a lot of diversity, trying to target 30 species, which is not practical in all situations. I like to go more on an ecology base where you're referencing a forest community that's nearby and taking cues from that community. So if that community only has 10 species, then you can utilize that. But I'm getting ahead of myself. I'm going to cover that when we go into some project samples or examples. So yeah, I had mentioned Shubhendu Sharma and Afaras from India. He really popularized this method with a TED Talk in 2014. It's still available online. He trained with Akira Miyawaki. He worked in the automotive industry and was part of these kind of like big Miyawaki forest plantings that happened with the automotive sector that came out of Japan. And there was a factory that he was working at in India. And so when he was part of this, he was like, I'm changing my career. I'm gonna do this. And so he has been promoting it ever since. And then he went up to Belgium and to the Netherlands and started training some folks there on the Miyawaki method. So there's a lot of activity in Western Europe and India, and of course a lot in Japan. The oldest ones are about 40 years old, and they're over there. There's a bit in Australia, scattered throughout North America, a bit in South America, and in Canada, we really have only just started trying this method out, seeing how it goes last 4 or 5 years. It's pretty recent. I'm being generous. It's like the last 3 to 4 years. Yeah, so in Canada, there's a lot of activity in Ontario and some in BC. The city of Calgary is super keen on this. So they've been planting mini forests in parts of the city that are typically forested. So I added this layer because I just wanted to note that I'm not recommending that we plant mini forests everywhere. I think you need to take cues from the landscape. So it wouldn't really be super responsible to be planted up here or up here. at least not yet. We really do try to encourage those who reach out to us about mini forests to inventory their local forests and then to kind of mimic that with their plantings. Should I be taking questions throughout, or do you guys want to just wait till the end? Just wait till the end. Okay.
Yeah.
All right. Okay. Yeah, so this slide I put together for tonight, because I'm going to cover 3 forest plantings that I've been involved in that are sort of close to here, that are all publicly accessible, so you can go check them out if you're interested. So the Toronto Zoo Leslie Lookout Park, which is a new park that's going to be unveiled this summer, and it's right by Tommy Thompson Park, if you know, like by the Leslie Spit, but on the waterfront. And then Windermere Basin, which is in Hamilton. All right, so Windermere Basin is the first, and it is the oldest of the 3. This was planted, this is the oldest, as in it's like a whole 2 years old. We worked with Green Venture, which is a local environmental group, and the city of Hamilton, along with the Network of Nature, to install a mini forest at Windermere Basin, which is basically a fill site. And we had some soil brought in that was left over from various cemeteries. And then we got there and there were these massive piles of mulch, and we had all these volunteers coming and we're like, oh man, this is the worst. So we were like trying to rake it out as quickly as possible. And the soil that had been dropped obviously had a lot of seeds in it. So it was like full of weedy plants. We coated it with very thick mulch, which actually turned out to be pretty great. It meant because it was never watered, and these little herbaceous plants had no chance. They were like, so they just became kind of like the nitrogen in the soil to counter a lot of that carbon. But I mean, trees love carbon, so it's all good. So that's us digging it up and moving it around. And this is the day of planting. So this is just after, and this forest is about 600 meters square. So we kind of considered it 2, because generally the minimum size you want to go is 100 square meters. So yeah, 600 square meters, and we had on average about 3 plants per square meter. And what did we do? So yeah, there was the greenery underneath that we just smothered with mulch, and we added a little bit of compost and some mycorrhizal inoculants. So we had like actually it was my younger daughter was kind of the mycorrhizal fairy. She had like a bit of powder and she'd go around and people call her and she would drop a tiny bit into the hole. And she felt very important. It was a great role for her. Some more pictures. So yeah, so this is showing you the difference in growth. I tried to find images that have the same tree so that there's some reference point. We are doing quite a few measurements of this site, and actually Vineland Research and Innovation Center has jumped on board. Green Venture brought them in to measure carbon sequestration as well as the health of the soil. And the cool thing with this project, and I wish I had an image of it, is that this is right next to a traditional kind of tree forest or tree planting. So if you can imagine, they were leftover caliper trees that the city had nowhere to put. So they did these rows of massive caliper trees. You know, you can think of like they're 15 feet tall and have these big root balls, and they were planted in rows. And then these little guys, you know, are tiny right next to it. And they started, Vineland has been measuring the soil of both treatments because they're right next to each other, and have already found that carbon is being sequestered, not in the topsoil, but the subsoil almost at twice the rate, which just means there's a lot more microbial activity that's happening, and which is really great for trying to keep some of that carbon out of our atmosphere. Oh, there's the image. I had it. Yeah, so there's those guys. And also the survival rate has been better with the mini forest than these caliper trees, because as noted, the city did not have capacity to water any of this. And as many of you know, that larger trees go through much more intense transplant shock when they're put, because their roots have been decimated in transporting them, well, you know, pulling them out and moving them here. So they're not as resilient to the move, and they're not as vigorous as smaller saplings. So some of those have died since that image was taken. All right, the second one, this is the Toronto Zoo. Yeah, so I think the next slide shows, oops. Oh, I did something crazy here. Okay. I'll just leave that. Oh, I was supposed to show you. Yeah, so this is a little island. So this is the entrance to the zoo right here. Right, and we were talking with the zoo, and they're like, yeah, let's try this mini forest thing. We're like, yeah, let's. So we were talking about like going in other spots, and we're like, no, let's do it right in the front. It's just like in this like island that has 2 trees right now and a bunch of grass. And so we planted there, and then we used this forest because it's in the Rouge Valley. This is all actually there's some I mean, there's a lot of invasive species in there, but there's still some like mayapple and trying to think of something. I did see some trilliums, which I always think is like a sure sign that there's like a bit of health left in that forest. But there's a lot of beech and sugar maple and red oak. I'm trying to think of what else, some hickory as well. And so we created a plant list based on that to inform our planting. So this is the list. You can't really read it. And then these are the lists of local native plant nurseries where we were sourcing our material for our planting. And we did 3 plants per square meter as well for this. So there's an image. So yeah, this is the picture of the this is on the, like within the zoo. I just went out with one of the zoo staff and we inventoried what was there. And so this is a planting day. We planted in October, not this past October, but the October before, so 2022. And it hailed and it rained and it was sunny and we felt very Canadian as we planted. We left the trees that are locally native species, we left. So they're a bit bigger, but we figure it'll all shake out in the future. It doesn't matter. Yeah, so I mentioned a bit about what Vineland's doing, but also Naturemetrics is a company that we've started working with, and their work entails collecting small samples from soils and sequencing to see what species are in it. So not just plants, but like all species. So it's called eDNA, environmental DNA. And we're now comparing kind of the microbial communities. So not just the quantity, but actually the types of species that we're finding in these soils and seeing how and if these communities shift over time. So the one in the zoo was pretty degraded soil. We did add some compost. And we can get into how to prepare the soil if you guys want. I don't think I have slides on it here, but I'm happy to talk about how you prepare your site. There's different ways of going about it. So yeah, this is, they're kind of still going through that. We don't have any results at this point. And of course, this is all new. So it's going to take some time to build up any kind of valid data. And we also need to expand it quite a bit more to get more groups involved so that we can make some sound claims.
Can I jump into the question?
Yeah.
As you're doing your soil preparation, once you take all those measurements, do you do anything specifically to change the soil chemistry, like pH balance?
Like when we're preparing the site?
Yes.
We have not tackled pH at all. We're more just really looking at improving the biology of the soil. And we find that by doing that, generally that shifts the pH over time. Yeah, so no, but we're also like the last Windermere one, that was so last minute. It was so ad hoc, and we want to really set up some proper testing, but we're not there yet. So yeah, very beginning. And if any of you guys want to participate or explore this, please let me know. Yeah, like we didn't even, we did take a baseline in terms of the plant height at Windermere, but we didn't really do any other baseline collection. So with the soils, for instance, we're seeing a trend, but we don't have a before or after. Yeah. Yeah, I should, anyhow. Okay, this is the last site. This is Leslie Slip Lookout. So the first one was mostly with a not-for-profit and a lot of volunteers. The second was with the Toronto Zoo, and again with a lot of volunteers. This site's a bit different because this is part of a design project. So CCXA, which is Claude Cormier's, I don't know if you know of the landscape architect, he sadly passed away recently, but his firm's based out of Montreal. And they're the landscape architects who are leading this project, which is for Create-TO. We are doing a mini forest there, but it was to be planted by contractors. So we had to go through the detailed design process to relay this kind of new method. So I'll show you some of those images. And I think you guys, yeah, so you know, you guys been to Connie Thompson Park? It's a cool space. So that was a parking lot. And now it's being converted into a park. So this is the plan, and everything within the dashed yellow lines are to be Miyawaki method forest planting. And the idea is to insulate the space from some of the surrounding, because it's still a highly industrialized part of Toronto. There is some aggregate, not extraction, but transfer that's happening over here. There are community gardens across the street, but there's a lot of truck traffic that goes through. So we're hoping that they might filter some of that sound and capture a bit of that particulate that's in the air. And then there's some more kind of like typical park plantings within, and then a lookout tower and a beach. You can't swim there, but you can pretend while you're sunbathing, you know, that you're gonna go for a dip, and just you don't. Oh, okay. So yeah, the cool thing with this project was we wanted to look at, so you know, here I'm talking about these reference communities, but this is a part of Toronto that was on this was part of Lake Ontario at one point, right? This is all fill. So there is no reference community here per se. Before it was a huge marsh. It wasn't a forested space. So we wanted to look at referencing something else, and especially in light of climate change. So we were looking at perhaps doing some assisted migration. So this is a great resource that's provided freely by the Ontario government. It's mostly for seed transfer, but it works for planting. So if you want to collect seed from somewhere, you just put in your site, and then you choose kind of the climate model. So you can go moderate or extreme, and it will tell you so let's say, so I chose here 7E4, which is Toronto area. And it shows you in red the ideal places to collect seed for that climate scenario. So we went, we're not going to go down into the States, because that's like collecting from the States takes a long time to get over the border. So we aimed at Point Pelee, because it's a very southern part of the province. So there's an image of Point Pelee, and then we did some inventorying of the site, and then composed a list. So the plantings are happening on these slopes. So not only did we want to get forward, you know, the like canopy, subcanopy, understory, and ground cover, but we also wanted to take into account the different water regimes. So having drier tolerant species at the top of the slopes, and then at the base of the slopes, some that aren't as tolerant to drought, that have a higher chance of survival lower down. And the cool thing is that we were bringing in the soil so we could mimic the soils that are present at Point Pelee, which are quite sandy. In addition to the field surveys, so I had been to Point Pelee because we were doing surveys for endangered species, hop tree and dwarf hackberry, like a year before. So we had a lot of data, but just to boost that data, I often refer to iNaturalist. I don't know if Is anybody here familiar with using iNaturalist or Seek? Yeah. And so I just showing here, looking at what's present and always looking for that research grade, because it means that it's been vetted by other botanists and ecologists. And I can say that some of our best botanists and ecologists in Ontario do use this app. So I do trust it for the most part. There's always error, but it's pretty good. So that kind of filled out the plant list. I also looked a little bit along the north shore of Lake Ontario as well at different species to kind of inform the plant list. And the cool thing with Point Pelee is that a lot of those species are actually already planted in Toronto because they're really urban tolerant. Most notably, there's like honey locust that's kind of growing right by the shores. We included that. Some Kentucky coffee tree is another, trying to think, I mean, it's mostly chinkapin oak is really big here, which is not as common as a street tree, but yeah, it's a huge list of plants and definitely over the 30 minimum threshold. Oh, and I should also note too, because of all the particulates, we went mostly deciduous because we found when we were doing the initial arborist survey of the site, the conifers that retain their, or the evergreens that retain their needles all year were more impacted by the particulates than the broadleaf trees. So that's kind of, we're aiming for trees that can handle, hopefully, that site a bit better. This is an example of the design. So this was done by CCX's office. I don't know if it's kind of hard to read. So it's very detailed. Each of these squares, so each number actually represents a 1 meter square. So that's why I show you this goes even more detailed, right? So each square has the 3 to 4 plants. In the end, so this was really helpful, I guess, for organizing the upland and lowerland species types, and yeah, kind of helping the contractors orient themselves. But in the end, I mean, they just ended up planting them because it's just a little too detailed and controlled for basically what is a restoration method of planting. So here's an image of those slopes. So that was just with a stabilizing treatment. That was rough graded. It wasn't the final grade yet. It's I think I have, no, I don't. So it was planted out this past fall. So it's very newly planted, and we worked with Guyanaceae, which is a native plant nursery and restoration company based out of Six Nations. So they did all the planting and they also procured all the plants.
Did you say
Guyanaceae?
Okay.
Yeah. Oh, and I should note the another cool thing with this is that this is like total tangent, but I like find this so exciting. While I was in Point Pelee, I came across some blue ash, and as you know, blue ash have been decimated by the emerald ash borer. But blue ash, because they branched off from the other ash trees earlier on, they're just a bit more slightly different than the others. So then other than white, green, and black. And I found some at Point Pelee that had clearly been infected or like not infected, but attacked by emerald ash borer and were healing. So they were covering up those wounds. Those galleries were being covered up by wound wood. Yeah, so they were thriving. So I really wanted to put some blue ash in this planting because I think it's a travesty that we are no longer planting any ash because they need to stay in the landscape, right? There's 99 arthropods across North America that rely on ash to certain degree, like to varying degrees. Some only consume ash. And so if we don't replant ash and we just let that leave the landscape, then those insects have nothing to eat and they also disappear. Right, so keeping the blue ash, of course I can't get ash at any nursery, I mean, nobody's selling ash. So I went to the University of Guelph and they have a blue ash collection that they've collected, and they from Southern Ontario. So we collected seed, the University of Guelph collected seed and provided that to Guyanaceae, and then Guyanaceae propagated those seeds and they've been planted out. in this site. We also were trying to do that with slippery elm, which is another very rare species. But unfortunately, it was a bad seed crop year, and so we didn't get it. This past fall I got some, but we were looking the fall before, or like the summer before. So we didn't get that, but maybe we'll boost it at some point with some more species. Yeah, so I just put this slide up because you have a lot of resources available on the Network of Nature website if you're curious. And there's more coming. So we do have a full document that lists, it goes through everything of like step by step of how to install a forest, how to kind of pull together a plant list, which resources to kind of refer to so that you can do that. And we also on this website have we have a map of all the native plant nurseries across Canada, and according to the federal government, it is the most robust list of native plant nurseries across the country. So you can go there to get any more information, and there's some videos coming out too soon, like maybe within the next month. Okay, and lastly, and I have no idea where I'm at with time, so hopefully I'm like kind of around the mark. But lastly, I want to show you the mini forest city in my own backyard. So actually this is older than any of the other three I showed you. I'm just gonna props to myself. So this is when we bought the property. This was a privet hedge here, and we had some hibiscus, Rose of Sharon, some Sharon shrubs there. So we removed those, and then it was all grass. And I did the method of just covering with cardboard over grass. I pulled out some of the taprooted plants that were there, like burdock and dandelion and whatnot, and then smothered it with cardboard and covered it with compost, and then covered that with mulch. And then here's the planting. So I got these plants mostly, from a few different native plant nurseries. I also, with permission, collected some ash saplings from various people's properties where they had once had a large ash tree. There were some babies growing, in their gardens, and they don't want them. So I dug them up and I put them in my backyard. And our neighbor has like a beautiful large sugar maple. So with his permission, I collected some of those seedlings too. And then, this is more recent. So this was a year after. I did have some poplars, like some trembling aspen, which were growing a little too fast, and I decided to get rid of them. So I gave them to a friend, but then a year after, this is what it looks like. It's hard to get in there now, and that's after 2 years. Yeah, so and I do have some, so I kind of, I couldn't stick to like being a purist about the community type because, like when a friend gives me a couple of pawpaws, I'm going to throw them in there. So there's a mix. Trying different things. I have a rock elm in the very back, Shumard oak, which is pretty random, but it's doing great. I've got some hawthorn, which is fun because those are really underutilized, I think, in landscapes. And then just, like a whole mix. And it's great to see all the other kind of species that are coming in that I didn't plant, or I didn't, there's various mushrooms that are now showing up and all sorts of insects, which is pretty cool. So yeah, that's it. Thanks.